Experiment 1. Tan Shen attempt to spoof the Touch and Go e-wallet using a clay mold of his fingerprint. The goal was to test whether the app fingerprint authentication could bypass using a fake fingerprint. When he tried to send money to Tan Chongmeng using the fingerprint, the system responded with fingerprint recognition failed. Try again or enter the password. This indicates that the fingerprint scanner was able to detect the spoof and did not accept the fake fingerprint, suggesting a level of protection against physical spoofing attempts. In this attempt, Tan Chongmei attempted to spoof the Touch and Go e-wallet using the same method as Tan Shen by creating a clay mold of his fingerprint. When he tried to authenticate using a fake fingerprint, the app responded with, "Unable to recognize fingerprint, you have one more attempt." This shows that the app detected the fingerprint as invalid and limited to the number of attempts, forcing that it likely uses anti-spoofing measures to prevent unauthorized access using artificial fingerprint. The results from both Tan Shen and Tan Zhongmeng attempts to spoof the Touch and Go e-wallet using a clay fingerprint mold show that the system is capable of detecting fake fingerprints. In both cases, the app rejected the spoofing fingerprints and issued a security warning or limited feature attempts. This suggested that the fingerprints authentication features include anti-spoofing technologies and time limits, providing a strong protection against unauthorized access. Experiment 2. Tan Shen attempt to spoof the Touch and Go e-wallet using a printed photo of himself to bypass facial recognition. The spoofing attempt failed, and the app did not authorize the transaction. This suggests that the system can detect static image attack and likely use liveness detection to verify real faces. In this experiment too, Tan Chongmeng tested the spoofing resistance of the Touch and Go e-wallet system. First, he used his real face to authenticate initial a transaction. The system successfully recognized his face, and the transaction will proceed without any issue, indicating the face recognition system works correctly under normal conditions. Next, Tan Chongmei attempted to spoof the system using a printed photo of his own. The goal was determine whether the e-wallet face recognition could trick by a static image. However, the attempt failed, and the app did not authorize the transaction. This outcome suggests that Touch and Go likely include liveness detection features in his facial recognition system. This feature helps distinguish between a real-life person and a static image. In conclusion, the result of the experiment 2 demonstrate that the Touch and Go e-wallet is able to distinguish between a live face and a printed photo. This suggests that the system includes liveness detection, providing effective protection against basic spoofing attempts using static image. Experiment 3. Tan Shen used AI deepfake tools to test if the Touch and Go e-wallet could detect spoofing. So he attempted to send RM 0.01 to Tan Chongmei using deepfake AI tools. So after testing, the app responded with payment will be processed securely and may require additional authentication. So basically, this indicates that e-wallet may have security measures like biometric checks or multiple factors authentication to prevent spoofing. Now for the second trial of the experiment 3, our Tan Chongmeng used again the AI deepfake tools to spoof Touch and Go e-wallet by sending RM 0.1 by using AI deepfake tools. After trying, the Touch and Go e-wallet app responded with payment will be processed securely and may require additional authentication. So this indicates that the app include a security measure to detect and prevent spoofing attempts. In conclusion, the experiment 3 showed that Touch and Go e-wallet respond to AI deepfake tool spoofing attempt with security notice, suggesting that the presence of protecting features like biometric checks or additional authentication, while it does not explicitly block the spoof, indicate that further verification is required, potentially reducing the risk of unauthorized transactions. Experiment 4. In this experiment, Fan Shengxian attempted to spoof the Touch and Go e-wallet using a silicon replica of his own fingerprint. The goal was to test whether a more realistic materials could bypass fingerprint authentication. However, when he used the silicon fingerprint, the app failed to detect any fingerprint input and did not proceed with authentication. This indicates that the fingerprint sensor may include capacitive or optical detection features which can identify the absence of real skin properties, therefore rejecting even advanced spoofing materials like silicone. In this experiment, Tan Chongming attempted to spoof the Touch and Go e-wallet using a silicone replica of his own fingerprint. Following the same method previously used by Tan Shengxian, after applying the silicone fingerprint, the app failed to detect any fingerprint input and did not proceed with authentication. This suggests that the system can recognize absence of real skin characteristic and is able to reject artificial fingerprint materials. Conclusion. The result indicate that the Touch and Go e-wallet is registered to fingerprint spoofing using silicon mold. The app inability to detect the fake fingerprint show that it likely used liveness detection and advanced sensing to prevent unauthorized access.